I'm Molly Maskrey, Senior Data Scientist here in Denver, Colorado. I'd like to thank everyone for coming today. I want to discuss the use of LLMs and helping seniors being able to understand and pick the right plan to fit their needs. Primarily, I'm going to be talking about Medicare Advantage or Part C programs, but these ideas could be applied equally to many other areas. I began working in artificial intelligence back at IBM Federal Systems in the late 1980s, working in recursive algorithms, primarily using the Lisp programming language, if anybody might remember that. I formed a number of companies over the years, including Quantitative Bioanalytics, which was an AI-based company focused on senior fall prevention technology, using the Internet of Things technology, basically multi-axis sensors that would alert someone if a senior was having issues and problems walking steadily and was about to fall. I primarily worked in public health and market access for the last decade or so. I spent a couple years in the Colorado Department of Public Health Laboratory, primarily in newborn screening analytics. In the last 5 years, again, as a senior data scientist specializing in Centers for Medicare, Medicaid services, Medicare and Medicaid applications, social determinants of health, and CDC chronic disease analytics. So most of my work has been focused in market access and data-driven insights. That is really looking at market access pathways enabling pharmaceutical companies to get their therapies to reach the right target populations. As far as experience, I've had about 30 years both in aerospace and healthcare analytics. I was a paramedic and actually rode with the San Jose Fire Department for a while and spent a year here in Denver in the emergency department of a level 1 trauma center. I've worked in cloud systems, AWS, Azure, which is my primary focus now, and a little bit in Google Cloud, doing large-scale cloud-based analytics and AI analysis, particularly generative AI most recently. And finally, I've actually published or had published 5 books on software development and analytics. Currently, my day job has me focused on analyzing both public and private healthcare information, developing insight tools using things like Tableau, as well as various Python libraries such as Dash and Plotly. Now, so why Medicare Part C? Well, also known as Medicare Advantage. A couple of reasons. In January, I was invited to participate in a healthcare panel for Humana insurance company, a group of seniors, basically a senior cohort, to look at the issues surrounding the problems that they were facing, things like plan selection, things like what were their particular needs, because seniors typically have a large variety of variation in the things they want, from people that are just turning 65 and coming into the Medicare realm and are very active, play tennis, ride bikes, do things like that, to older seniors that have special needs, whether it's continuing care, supportive care, or various operations of that type of thing. So the existing tools that CMS provides, they're very good, but they're only limited by the sense that they will give you a side-by-side comparison of a few plans, but not allow you to pick particular things that are of interest to you. For example, I started with my Medicare plan about 4 or 5 years ago, and I was faced with, in my Denver zip code, 54 plans to evaluate. And I'm pretty active, so I had certain needs. I was looking at, maintenance prescriptions, things like that, as well as active programs, versus, I didn't really care if it was a specific provider or specific PCP, something like that. I was mostly interested in things that fit my need. But the tools that CMS provide don't really do that. So you have different types of patients. One size just doesn't fit all. You have active individuals, such as myself, chronic condition patients that may need specialist care and disease-specific coverage, or continuity of care seekers, prioritizing their current physician and network. So making the wrong decision can cause seniors who are typically, and I found this out at our advisory group for Humana, a lot of us are on, very fixed incomes. So it was kind of important to me, not only just for the people in the senior cohort, but people like myself as well. Here's an example of what you would see if you were to go as a Medicare Advantage, interested subscriber, and what you might see. You'd see things that stand out and look pretty valuable. You'd see the green check marks, the red check marks of what these plans do and do not provide. But you have to have additional support particular to the individual. Otherwise, everybody with their different needs is looking at the same information and not being able to have it tailored towards their needs. So they did a good job of getting the data out. There's just so much of it. Again, we're talking like in my zip code, it was 54 plans. That's 6 pages of 10 plans each to look through. And while there are clear summaries by plan, as you can see, it's still a lot to keep track of. So for the framework, first let me say there's nothing revolutionary about what I'm going to be talking about. Rather, it's an application of the space in generative AI and natural language processing where most of us likely work. The process is actually deceivingly simple, consisting of really just 3 steps. A pair of LLMs each select from a stack of these plans, a stack of the plan data actually, compare what a user enters in terms of their needs and or desires, and evaluates their plan against those needs and compares it against the other LLM that is looking at a adversarial, if you will, plan itself. So through a crafted set of prompts and a third arbiter LLM, one of the 2 plans gets dropped in favor of the better selection. The process continues as the next plan is popped off the stack, compared against the previous winner, so forth and so on. Once all the plans have been evaluated, the user is presented with the final selection along with how it best met the user's stated needs. The user can choose to accept the provided selection or amend their needs and restart the process. The system doesn't choose a plan for the beneficiary. It merely provides decision support, reducing the amount of time a beneficiary has to look through these pages of information. A simple diagram of the processing flow to illustrate. A user enters in free-form style what they want. And this is where the effects of generative AI really help us out here. That gets vectorized and compared to previously vectorized plan details to pull the plans that best meet. They're the nearest match in vector space, the user's needs. This is intended to be a first pass reduction. Plans that are closer to the user's vector space are processed, while those that are far away are not. For example, if a user is set on not having a monthly premium, those that might have a $500 monthly premium are readily discarded almost instantly. The augmented prompt, so this is basically a RAG model, is passed to the LLMs to make a determination, which is eventually passed back to the user to help support their decision. So an example of a user such as myself who tends to be a little more active could want the lowest premium. I might want active lifestyle programs, wellness programs, yoga in the park, tennis. And also I might have things like dermatological needs or, that type of drugs where I want to find the lowest prescription drug costs. So through careful prompting and trying to eliminate bias, an objective decision is made on scoring the two plans and passing the one which comes out on top to the next state of comparison. Should the two plans be close that their prospective models can't decide, a tiebreaker is used. So here's an example from that data I was looking at earlier that actually comes from the CMS site. LLM1 might pick up a United Healthcare plan, and there's a contract number which usually begins with an H and a four-digit notation, as well as a three-digit plan ID. And so that LLM might take on an advocacy for that United plan. Similarly, there might be a next plan down the pipeline, might be a Kaiser Permanente plan. This might have a premium, so we can already see that there's going to be a difference between what my needs are and what this plan has to offer. So what would happen at a top level is LLM1, you could think of it as talking to LLM2, and this is a pretty typical kind of thing where you have these adversarial cooperative relationships, sort of like generative adversarial networks from a few years back, where an LLM1 would advocate the United Healthcare plan, pointing out its lower drug costs, its zero premium, and direct access to, active programs, that type of thing. And finally, the decision goes through, tiebreaker is not required. These guys sort of get the idea and can pull out and pop off the best plan of those two that are being looked at to be compared to the next plan in the pipeline. So, vectorization, what is it and how it works? So, the process handles vectorization by compiling snippets of information from CMS into more complete sentences for tokenization. So you might have words like monthly premium includes this, part B that, so forth and so forth. These get turned into sentences that can be used to create embeddings, as we'll see next. So the sentences that we pass to the vectorization algorithm gets placed into chunks. The text is chunked into a defined size with a specific overlap to ensure that the context is maintained to generate a set of embeddings. Here's an example of the OpenAI tokenizer so you can sort of see what happens. You might take the example prompt that would be built and passed to the tokenizer or to the vectorization algorithm. And you can see the different colors representing the tokens that are pulled out of the structure of that information that is passed along with the prompt. So the text is first split into tokens based on the tokenizer rules, and the tokenized input allow the LLMs to process the text efficiently. Now, we're not actually sending tokens there. What we're actually sending is token IDs. Token IDs, which might be words or pieces of word. Typically, what you'll hear out there is a token is about 3/4 of a word, and that tends to be pretty much the case that I see. So these token IDs are numerical representations, which are thus machine readable and able to be processed by the specific LLM. Again, this is pretty much all standard stuff. And really what I'm talking about here is a way to take the science of NLP, of generative AI, of LLMs, of RAG models, and use it in a constructive way to do things, especially in the healthcare space, in particular around the senior cohort. An example user interface here I developed simply using Gradio as a way to test this out to see if it worked. Is I have a way I can enter, I need a plan with zero additional premium, such and such. So a user can enter free text, they can enter blocks of words, of things, however they want to do it. We could build an interface that would have pull downs, things like that. But I found the free text tends to work just fine. Comes out with processing status and a recommended plan. So you can do it, make it very simple for a senior to use where they don't have to go again through 10, 12, 15 pages of different plans with 8 or 10 plans per page and dig through and try and find out what's their best option. So I covered all of this pretty quickly, mainly because, again, there's really nothing very new here, but rather it's an application of popular, recently available technology. For me, it's putting really cool stuff to good use. So again, there's a definite problem that I've not only been a part of discussions with in the Humana advisory group, but I've also had to face this myself. I've had to deal with those over 50 plans to choose what I needed. The way it's been done is still confusing for many seniors. I mean, I heard this time and time again at our council meeting. So I looked at using language processing, generative AI, as a decision support mechanism. And an interestingly, a point here is most of the seniors in the group were aware of AI type of processing. They've used bots for some times, and there's kind of mixed reaction on there. But all of them were in agreement that something simple, easy to use, whether it was AI driven or somebody, an actual person on the phone, helping them decide based on their needs would be what they really are looking for. So honestly, I'm not sure if this will go anywhere from here with the changes, at CMS, with the changes, HHS, all that. As a major overhaul of a system like CMS Medicare plan selection seems unlikely, but I do think some of the bits and pieces of what I've discussed are applicable in other areas, especially things like adversarial-comparative use of LLMs to pull out decisions and try as best as possible to eliminate bias in AI decision making. So that's really all I have to say. I want to thank you for taking the time to listen to my talk, and I hope you have a good rest of the meeting.